Okay, on this one we have a 5 meter long ladder that rests against a vertical wall. So this is 5 meters. Here's the wall. And okay. The feet on the ground start to slip within instant, let's see, at the instant that they are 3 meters from the wall. And they're moving at 10 meters per second. Okay, so at what speed is the other end of the ladder moving? Okay, so what we're going to do, we'll call this A, call this B. This will be our origin. And we'll start without plugging in a particular value. So let's just call this X, and we'll call this Y. And we can use Pythagorean theorem to say x squared plus y squared equals 5 squared. So x squared plus y squared equals 25. And then we want to take the derivative because we're trying to do the rate. And we're going to do it with respect to t. So if we take the derivative here, it's 2x dx dt. And this will be 2y dx dt. And then the constant will just be 0. And if we divide everything by 2, we can be x dx dt plus y dy dt is equal to 0. Okay. Now we're going to plug in the particular value. So we have a 3, a couple things. So our x value is going to be 3. Our rate, our original rate, is 10. And then I think they gave us y. Let me check they didn't give us y, but we can use Pythagorean theorem to figure that out. So if we go 3 squared plus y squared equals 5 squared, that's going to be 9 plus y squared equals 25. Subtract 9, y squared equals 16, and y equals 4. So we can plug in a 4 for y. And then dy dt is what we want to find. They want us to find the rate of the other end of the ladder. And when we do this, we get 30 plus 4 dy dt. Subtract 30, we get 4 dy dt equals negative 30. Divide by 4, divide by 4. So dy dt is equal to negative 7.5 meters per second. And so the other end of the ladder is moving down the wall. The negative implies that at this rate, at that instant. Okay, now we have triangle ABC. It's right angled at A, and we're told that AB is 20 centimeters. ABC increases, so this angle increases at a constant rate of 1 degree per minute. At what rate is BC changing at the instant? So BC changing at the instant that ABC equals 60. Okay. So we're going to call ABC theta, and we're going to call BC x. Okay. So we can use trig. We can have adjacent hypotenuse. So cosine theta is equal to 20 over x, which we can write as 20x to the negative 1, which is going to help us take the derivative. So we'll take the derivative of both sides with respect to t. And so the derivative of cosine is negative sine. Then we get d theta dt. And then we bring the -1 down, x to the -2, and dx dt. Okay, now we're going to plug in 30 for theta. And so in the original, we can solve for x. So we're going to say cosine of 30 is equal to 20 over x. Cosine of 30 is square root of 3 halves from our unit circle. We can flip both sides and then multiply both sides by 20, and we end up with x equals 40 over root 3. Okay. Now we're going to convert our rate of 1 degree per minute, and 1 degree is the same thing as pi over 180 radians per minute. Okay, and so when we look at the derivative, we're going to plug in some values. So negative sine 30 degrees times that by pi over 180. And we have negative 20, and then we plug in our x value. And we still have dx dt. Okay, so sine 30 is going to give us -1/2 from the unit circle times pi over 180. This, we're going to flip it upside down and then square it. So it's going to be like, because of the negative, and then when we square it, we get 3 over 1600. Then we times that by 3, or by -20, and we get -60 over 1600 dx dt. And if we simplify that, we get -3 over 80 dx dt. If we multiply this, we get -pi over 360. Okay, multiply by the reciprocal over here. Those negatives cancel. We get 80 pi over 360 is equal to dx dt. And if we just plug that into a calculator, we're going to get about 0.233 centimeters per minute. Okay, so we say that x, or BC, is increasing at approximately 0.233 centimeters per minute. If you need additional help, please come to Math Lab. Until then, calculate.